So now is the large research is about the effectiveness of laser welding in cerclage wiring fixation, a biomechanical study presented by Dr. Nachapan Peng Rung. Please, Dr. Nachapan.
Good morning, Chairman, Co-Chairman, ladies and gentlemen. My name is Nachapan Peng Rung from Lama Tibeti Hospital. I'm going to present my research in the topic of effectiveness of laser welding in cerclage wiring fixation by the part of biomechanics. I think all of you in this room has a lot of experience in wiring. It's because it's very common procedure. It's familiarity, cost effectiveness, and reliability biomechanic property. It can use as a definite fixation and also reduction tool. But however, the fixation failure is still often found. Rate is up to 70% in some literatures. The two most common scenarios of fixation failure are: the first one is over tighten of the wire. When you twist, it's over. It occur the plastic deformation, weak point, and then breakage. And another scenario is under tighten, and then it's untwist and loosen, and also lost the reduction. So that's why we interest in welding technique or in tie hole outlet. The method is attach or fuse the two wiring parts, two wire sides together. And we also use the laser welding technique because it's more precise, low heat, fast, and low error compared to other welding technique. So our objective are from the gap of knowledge that there are no previous study to do the laser welding in orthopedic fields. And so we want to compare the biomechanical property of cerclage wiring with laser and the conventional wire. And we want to know the clinical safety. In this part, I focus only in vitro hemolysis test. My method, we use the synthetic bone and cut as the figure, and use the stainless steel wire diameter 1.5 millimeter. And we tighten into 5 configuration consists of the single loop. The second one is single loop with laser on the spot that is connect. And another one is conventional double loop, and the last one is double loop with one side of welding, about 5 millimeter, and the last one is double loop with 2 sides of welding. And we use the laser parameter as shown in the table. This came from our previous study with collaboration with our team engineering, which test the tensile traction at the simple wire fusion. And after set up the biomechanic test at the figure, we use the tensile load to apply to the specimen at rate 15 minutes. And we measure outcome in part of load to failure and the mode of failure. And for the in vitro hemolysis test, we random 3 specimens from the single and double wiring groups and test the in vitro hemolysis test according to ACM protocol. And after that, we interpret the result of this outcome. If the hemolysis more than 5% is not acceptable for human use. And this is our result. It's confirmed that the double loop wiring provides significant better biomechanic than single loop, as all of you know. And if you focus only in the double loop groups, either one side or 2 sides of weld provide significant biomechanic than the conventional double loop groups. But there are no significant difference between laser and without laser in the single loop. And for the mode of failure, 3 in single loop with laser and double loop is failed by untwist of the tighten wire. And the last 2 groups with 1 laser or 2 laser is break at the wire near between the laser and the twist. And this is the list standard is break. And for the hemolysis test show mean percentage of all specimens less than 1%, and so it's no hemolysis. In part of discussion, our results show that the double loop with laser, either one or two sides, provide better biomechanical strain and has different mode of failure compared to conventional. We think that the laser increase the biomechanic property because it reduce the stress on the wire and distribute the tensile load at least area. However, in the single loop groups, it also add the stability but not significant. We think that it's because of very small welding area, about 0.7 millimeter. So we may design another technique for weld in this single loop. And in hemolysis test, no acute adverse event from welding, laser welding. But however, we not focused on other adverse events such as the thermal, the corrosion, the long-term release. So the previous publication from biomechanics and clinical safety that in the literature show only in the dental application. So I can conclude that the laser welding increased the biomechanical strain in double cerclage wire fixation and hemocompatibility. And however, biocompatible and clinical studies still need to compare. Thank you.
So thank you very much for so innovative research.